All right, good morning, everyone. How we doing? Lou? My name's Tom Myers. I'm one of the senior architects for Accenture's cloud platform, and I'm going to talk about what ACP, our Accenture Cloud Platform, does with serverless, some of the things that we've learned internally building that. And with me is Matt Lancaster. Matt is Accenture's global lead for lightweight architectures, and what that means is Matt takes things that we've tried out internally in places like ACP, and he takes those lessons out to our clients so they don't have to feel the same pain we did as we were building stuff out. So I'm going to start, talk a little bit about that, and then I'll hand things over to Matt, and Matt will tell you some nice stories about some things we've done at our clients. I've got a lot of charts and a lot of pictures, and they gave me a laser pointer that is this big, so you may or may not see what I'm talking about, but one of the benefits is that there are mics at both sides, and we're going to try desperately hard to leave about 10 minutes at the end for questions. So keep that in mind if we say anything, well, I won't, but if he says anything particularly controversial. All right, so we call it the Accenture Cloud Platform. And what we did is we've had this thing for a number of years now, but we decided what we needed to do is really focus on making it into a true platform. The quote up on the screen is from a book by a guy named Amrit Tiwala, and it's called Platform Ecosystems, and it's really all about the things that you need to know principally for what your platform should do. And so we started this initiative, and it's called Platform S internally, so platform for serverless, or any number of other ways you can interpret that. And so the key definition that we took from that is that we're really bringing two different groups together and enabling them. So what the Accenture Cloud Platform is, what it does is we like to call it an on-ramp to the cloud, right? We have large enterprise clients who are looking for a way to get into the cloud, and they're looking for somebody who's been there before and done it and has, some things in place. Enterprises need things that not everyone needs. They need governance, they need analytics, they need transparent billing. And so the ACP platform puts that stuff out there, and then we enable our development teams, people like Matt's groups and others, to go in and use those services that we've already built, use the APIs that we build to make their offerings, and then we provide a way for them to offer those to our clients so they can consume them relatively quickly. We started in a data center, just like most on-prem stuff did, hosted data center, and then we evolved that into Amazon Web Services using some virtual private clouds and VMs. And now what we've done is we've taken some of the principles of serverless design, which we're going to talk through how we did it and what we did, and we use those now to step it to the next generation. So the way that it works, the way the ecosystem works, like I said, Matt's group is on the left, and our large clients are on the right. Here, I'll use my cool pointer. You can't see it. Oh, yeah, I can't see anything. And then in the center is ACP in that cool circle diagram. I'll show that in a second. So that we build APIs in the middle, in the very center of what we do, and then we allow the developers to use those APIs to then make the offerings that we need to offer. So why are we doing serverless? Well, as I said, ACP is a big collection of services, a big collection of APIs, a big collection of things that people are using to enable other activities. Anybody who's been studying this for a long time, and as Accenture has, you know that a microservices architecture is really the right way to do those kinds of small services that are working together. And if you look at the serverless platform, the serverless design, the serverless systems that are out there, that's purpose-built for offering things like a microservices architecture. So why are we using AWS? Well, first of all of our stuff's in AWS, so that was very handy for us. But more importantly, AWS's serverless stuff is far way ahead of everybody else's serverless stuff. That's why we were starting a year ago to do all of this, because it was there, it was largely ready. Things like Lambda were already ready, things like API Gateway were already there. Secondly, there's a lot of open source and tooling and other things out there to help you get into serverless, so you don't have to make this stuff up or build it yourselves. There's a lot of footholds out there. And then thirdly, we have a partnership with AWS. We have the Accenture AWS Business Group. We announced that a year ago here at AWS. It's a year old. It's phenomenally successful bringing the power of AWS to large enterprise clients. So like I said, everything AWS makes good sense for us. So when we talk about our serverless design, I'm going to talk through the components of it in a few minutes. We needed to have a way that we can build this in this new Platform S that allowed people to start taking advantage of the services that we were building, but still allowed us to innovate and make new changes without disrupting what they had already built on top of our systems. So we came up with this ring model. And in many ways, it's like an operating system works on any kind of a system, that at the very core center of it are the fundamental things that we're worried about, the things that are going on all the time. So in our case, that's where we're building APIs. That's where we're building core things like discovery of resources that are out there, a billing engine, and things like that are in the very center. By putting those in an isolated place, using APIs that have versioning, an API contract that we make with our clients, we're able to use a continuous delivery model to push out into that environment. So long as we don't disrupt what the agreement is, we can just continue to add new features, we can make bug fixes, and so you end up with a pretty high quality API because it's constantly being fixed, constantly being deployed to. In the ring around that, we call that ring 1. That's where the applications themselves live that we build, the stuff that we care about, things like our UI, things like our analytics tools, things like our billing services. Those live in that first ring because they're very, very dependent on the services underneath them in that core ring. And in that ring, we use an agile deployment mechanism because we can quickly do 2-week releases into that environment. But you don't want to, it doesn't have to be continuous delivery, and so we're able to take the time to push that through more traditional channel. And then in ring 2, which is the outside ring, that's where people like Matt's groups come in and they develop client solutions. They can leverage anything in ring 1 or ring 2 or ring 0 underneath that, and they can use any kind of delivery mechanism they want to because there are no dependencies on what they're building other than the dependencies that they create for themselves. So with that ring model, everything depending on the one inside, that gives us the opportunity to start building systems that look kind of like this. So you're going to really be able to see my phenomenal PowerPoint skills when I do the animations that go along with these slides. But essentially, I'm going to take you left to right through our serverless architecture. This is an example, and then I'll do a couple of specific ones towards the end. But basically, everything begins, see how cool that was? Basically, everything begins when somebody clicks on a mouse and tries to do something or makes an API call to do something. Now, we're Accenture, and so we want all our stuff to end in Accenture.com. And Accenture has a very tight IT department that isn't going to let me just start making up Accenture.com domain names. So we all have to go through central IT. And so, of course, Accenture's internal CIO or internal IT group owns all of that. And then they give us CNAMEs out to the things that we request. And those CNAMEs push out to our Route 53 implementation. And it's at that point that we gain complete control. So we can do anything we want. We can point it to any endpoint we want. And if we need to change it from pointing to Lambda to API gateway to whatever we want to point it to, we make those changes and no one needs to know. And so long as those changes are coded and done in a scripted manner, everything works out perfectly, he said. So the next step is where those endpoints are. And by and large, they're all landing on a CloudFront distribution. In the case of our artifacts and our UI, those are in an Amazon S3 website bucket. We have like single-page web applications out there using different languages to make AJAX calls over to our APIs. We use an API gateway with a custom domain name, and that gets you a CloudFront distribution for free. The beautiful thing about using custom domains is that you can create as many different API gateways as you want to. You can have different people design and develop them, and then you just string them together under your custom domain name, and they just become paths of the same API domain, and that API domain travels all the way back out to the security certificates that we've put in place from Accenture's home office, and so it all works nicely together, and those APIs can be redeveloped, changed, upgraded, and whatever without having to make any changes to any of that overall security that's out there. But of course, it's CloudFront, so you get a huge content delivery system out of it as well. And that gets you a number of things that you need. It gets you endpoint caching. It gets you lower latency around the world by using regional distribution points. So you get a bunch of things for free just by using a reasonably intelligent design technique. So then When we implement those APIs, everything starts at the API gateway, and then it goes into Lambda. Not everything goes into Lambda, but Lambda is where our business logic is. And so we use Lambdas to implement the various things that need to be calculated or need to be moved around. And then we do inter-process communication between those Lambdas using Redis for caching, or we use SNS for messaging back and forth. And then we use a lot of Kinesis streams. Kinesis is fabulous for enabling us to shove data into a stream and then have multiple API or multiple Lambdas down the road reading those and processing those and doing whatever they need to do. And I'll show some more details on a couple of examples of that in a minute. So for persistent storage, oh, did I skip this one? No, here we go. For persistent storage, we use Redshift, we use Elasticsearch, and we use DynamoDB. So once you've queued up all your messages and they've gone for processing, eventually you want to store some data somewhere. We find that Elasticsearch really worked well for us. I'll get some reasons on another slide that I'll show you in a second. But again, these are all services. They're really easy to use. And so you end up being able to put together end-to-end all of this. There's no servers in any of this anywhere. We're not paying for servers or maintaining anything. This stuff stands up and tears down. Our continuous delivery mechanisms can deploy 10 or 20 times a day. You could do more than that, but generally speaking, our developers don't code that fast, to be honest. So then we also have CloudWatch at the bottom. That's the cool green thing. And that's really what's enabling our operational components, because with CloudWatch, we get all the logging and we get a number of alerts and things that come from there. So all the components we're using there in the list on the left, I talked about most of those. We have separate accounts for each of the different rings and each of the different application lifecycle stages that those rings use. This enables us in a couple of ways. It gives us a simplified security mechanism because we can define the security in an account without having to think about how I separate my production section of my one account from my development section of my one account. They're simply different accounts. And so if you haven't enabled communication between the accounts, then there is no communication between the accounts. That's actually a pretty nice security model if you think about it. So we have about 10 or 12 different accounts that we're using right now to enable both that core area and then that first ring around it. And then the second ring around it is really enabled by any number of different accounts that the client teams may want to themselves be using or shared. But so our DevOps pipeline takes the development code and it pushes it up through those different accounts and through the lifecycle stage there. Most of our Lambdas are coded with Node.js. Some of them are coded with Python. Usually the distinction between those is that if it's a utility type application, it's going to be Python. And if it's core business logic, it's probably going to be Node. We use Apex to manage that code at the deployment level. And we use Terraform to manage the infrastructure that the code runs on. And then we have a custom framework that we built around Apex and Terraform. I'll talk more about that in a second. All of it gets checked into Bitbucket and then gets processed using Jenkins jobs. We also use some Sonar and other code quality and linting and things like that. All of that's enabled by the Accenture DevOps platform, and we call that ADOP. And what that is a collection of really best-in-class tools that everybody's already using. And we enable a quick way to stand those up. We have an open source repository for this. I'll show you the link on the next slide, which enables people to just simply stand up whatever components they need to use and then just begin using them. And then we put our state files for Terraform. If you know anything about Terraform, it puts state files out there to control remembering all the stuff that it's built. And the state files we push into S3 so that we can share them. We have globally distributed teams, and so we needed to have a way that we can have those guys working together, but still, not have to be, for example, mailing state files around or something like that. So we had for the initial try of this, we tried to use CloudFormation, and unfortunately, CloudFormation, when we started using this a year ago, didn't really support API Gateway. And they had some other challenges. So that's why we went to Terraform. Apex did a super good job of managing the code. But we needed to do some additional things. So we put together a platform around our deployment structure that's written primarily in Python. And that platform does a few things for us. It handles the state files by pulling them out of S3 merging them together when they need to be merged together so that different groups can work independently in different places in the world and then still shove their state files into a common place where they can be brought together and merged together. We used a model-driven architecture, so we build simple CSV files that have the metadata for what we're putting together. And then within the platform itself is the logic for how each of these different patterns work. For something like API Gateway has a bunch of stuff that's involved in it. There are lots of things like IAM policies and transitions between the translations that happen inside of the API Gateway between requests and pushes and posts and so forth. And so all of that is handled in these patterns that we've defined inside of the platform, and then the platform does the generation of the underlying Terraform code to push that out there. And so everything is really very, very simply designed. That enables us in a couple ways because it can get developers that haven't really worked with this technology up to speed very, very quickly, because all they really have to understand is what they want. And then they simply describe what they want in these CSV files. Oh, and that was the picture there was the link to the DevOps platform, which is out on GitHub. So we ran into a few challenges that made us create this platform in the first place. We found that with CloudFormation, there were some challenges I mentioned. With API Gateway, there was a lot of complexity. And so we just put all of these challenges and we said, let's solve them in one place and then take care of that. And then the next guy doesn't have to worry about that. And that's sort of what we were trying to do with the whole thing. Here's some lessons learned that we talk about. You can write Lambdas in lots of different languages, but we really recommend picking one. Your developers may want to use whatever language they want, but then it becomes very difficult to have any kind of standards enforced. By using our DevOps pipeline, these Jenkins jobs that do code quality using things like Sonar, it's much, much easier if everybody's coding in the same way, coding to the same set of standards. It's super important, and I probably should have made a whole slide for this, to get your security done up front. Know what your security model is going to be. How are you going to enforce Lambda's access to different things? How are you going to control who can hit your API gateways? How are you going to do API security? Get all of that defined up front, and also your logging. Get all of your logging models defined so that everybody's logging in the same way, because then that enables you to take those logs and process them and use that for your operations that comes later. I got a slide that shows how we do that in a second. So we got some benefits out of this. Obviously, we wouldn't have done it if we didn't think it was going to be beneficial. And some of them were really huge in ways that we hoped would happen, but didn't necessarily know would happen. We're a large enterprise. Accenture's huge, right? And so we have these challenges that other large enterprises have, where we want to deploy something, but we have to ask the group that does that to deploy that thing for us so that we can then put our code out on it. And so we can write great code and it's ready to go, but it takes a week for somebody to actually deploy something, and did we get the PO, or did we get the approval, or did we get whatever else we needed? So by using the DevOps pipeline and getting that process approved, and making sure that that process included all of the testing components and all of the release management components, and things like being able to generate out your documentation from your Swagger definitions and things like that, all of that gets approved up front, and then as you release code into that mechanism, you don't have to get approvals for every single different thing you're doing, including the creation of new infrastructure or new components, because it's really just more code, and your code process is now approved. And then the API versioning was a big benefit for us, because we can make the agreements with the consumers at that Ring 1 level that we're going to use versioning and how that agreement is going to work, and so long as we don't violate that, that gives us this ability to do continuous deployment. All right, so a couple of patterns that came out of this, writing with Lambda, surfacing Lambda with API Gateway. Most of these are fairly obvious things, but again, just stuff that you want to make sure you go through. Doing communication between the services, and again, this is microservices architecture, right? You need to be able to isolate out the functionality so you can update it, so you can improve it, but also so you can gain the efficiency of scale. right? Lambdas work best when they can span out to, thousands of iterations running at the same time, doing different bits of that processing. And so you have to really write for efficiency there. You have to make sure that what you're reading out of the Kinesis stream is reading in the right block sizes and things like that, so that you're taking as much advantage as you can, and then queuing up or pushing back into Kinesis for the next step so that that communication is there. We found that putting our storage into Elasticsearch ended up making way more sense than any other database technology, because the way that we wanted to access it was with complex queries. So when we would write a new Lambda, we didn't want that Lambda to have to really understand some database schema, how we were storing things, so we can simply query it. Elasticsearch has a tremendous language for being able to against it, and so that enabled us to very quickly add new functionality that goes after that core repository of data. And then some data we do put into Dynamo, a lot of time series data, and it's especially important that you go ahead and timestamp your data when you put it into Dynamo, because that allows you to do some purging, right? I want to get rid of everything that's 2 years old or 2 weeks old or 2 minutes old or whatever the use case might happen to be. So this is an example of our first architecture that we brought online 6 or 8 months ago, I think now at this point, maybe not quite that long. And this is a hybrid integration mechanism. So what this does is for enterprises that have ServiceNow, or they have System Center, or whatever they have on premise, they want that to know about their cloud. And they don't like it when you say, oh, well, you don't need that because it's all going to be managed in the cloud. They want it to be there. And so what we are able to do is write a number of Lambdas and use things like AWS config and other tools to be able to go and get the resources out of the cloud, to take that infrastructure, map it into our own internal databases so we know what's changed and when it's changed, and then either push it or put an API out there that allows them to pull down those changes and make them look like service requests into ServiceNow or whatever their ITIL model may happen to be. And so it really enables that communications between the two. And again, so we talk about what ACP is doing, and we have these core services. So this core service sits there running all the time. And when you onboard with us, what happens is you define what you have on premise, and you define what accounts you're using, and then that just sort of falls into the processing mechanism. At the bottom, I talk about the operations model, and I have another slide on that next. And the operations model takes all of those common logs that are coming out and enables us to look at those logs and process that. So the operations and monitoring, when we deploy Lambdas via Terraform, via the Apex mechanism that I was talking about. And every time we do a deployment of a new Lambda, we actually have a secondary Lambda that lives out there that watches for that. And when it sees it create a new log system, every Lambda has log into CloudWatch, it sees that new log going into CloudWatch and it automatically assigns it to a CloudWatch log group. That log group is automatically subscribed into a Kinesis stream, so those logs, as soon as they're being published, are going into Kinesis. And we have a couple of other Lambdas that are watching the Kinesis stream, one which takes those logs and puts them straight into Elasticsearch, and that enables us to go into Kibana and look at them, or query them out as we need to. And then another one parses through them and pulls the data out of that to do things like alerts and metrics that we want to keep in our internal database. Now, we also use CloudWatch for that, but you probably know CloudWatch only has access to the top-level data. It doesn't really know what the business data underneath that is. And so what we do in the logging is we're sure to put the client ID, for example, that goes in there. It's multi-tenant, so we need to know what client we were processing for that took so very long or not. And we need things like correlation IDs that allow us to string together the Lambda executions as they go through the process. All of those logs get pulled together into a single common core place and merged together with the other overall CloudWatch data. And then all of that enables us to put together something like a health dashboard. And the health dashboard enables our operations guys or our client guys to go in and they can say, oh, I got a red flag here, let's see who that is. Oh, it's just this one client because their on-premise system is down, their VPN is down, whatever it may happen to be. And so we don't think we have a systemic problem. We can really trace it down to what we need. And then we can jump over to Kibana and we can actually pull up the whole log chain. So that's what we're doing today in ACP, and that's how we've already begun using this stuff. And I'm going to let Matt talk for a while, and he's going to talk about how we take that out and give it to our clients. There you go, Matt.
Fantastic. Alrighty. How many of you are building applications on a serverless architecture today? Okay, good amount of the room. How many of you are having some delivery challenges, some orchestration challenges, and other delivering those applications? Pretty much almost the same group of people. So I want to talk a little bit about the current state of how folks are building serverless applications out in the wild, and some of the things that we've observed from being in the trenches over the past 18 months that have de-risked a lot of those delivery aspects, have sort of improved how our clients and we have gone to market and done some of these things. So what I want you all to take out of this is, I think we in this room are responsible for building the next generation of awesome value-creating applications. And if we're going to do that with a serverless architecture, there are some obvious pitfalls to avoid, because we've been down that road before. It doesn't necessarily end well. And there are some things that we can do to really improve the quality of the end product, and also, de-stress all of us as developers and architects, right? So what do we observe today? What are some of the sins of the present? And I think the first and most obvious one is something that almost as every new technology or every new pattern or way of doing things comes out, we sort of rehash this problem. I remember arguing with people like 15 years ago, doing the same thing with Perl scripts that were just sitting all over the place, managing their entire environment, and nobody knew what did what. If we fast forward 15 years now, today, folks building serverless applications, you see little Python scripts and Bash scripts, and there's a Ruby script over here, and each team has their own way to manage the different services and different pieces of the application. Sometimes even in the same product team, you'll see some folks that are managing things slightly differently, and it ends up getting you a real nightmare, and we'll talk a little bit more about that. Lambda is fantastic. It's wonderful. It's going to help us, do all kinds of amazing things. But I think we're sort of at the top of the hype cycle, right? Everybody's drinking a bit too much of the Kool-Aid. What I have observed over the past 6 months or so is that as folks are starting to build some of these quote-unquote serverless applications, Lambda is used for all kinds of stuff, and we'll get into some of the pitfalls of that. But the TLDR of that is, use things like the API gateway, use Kinesis, use some of the other services that are still, you're still not managing infrastructure to alleviate some of those issues. And the next one is almost blindingly obvious, but since I see it so much, I figure we would put it there, which is folks are trying to reuse existing Node.js code by throwing it into Lambdas and calling it a bunch of functions, right? And you end up getting, interesting situations like 30 megs of JavaScript trying to push into a Lambda, and then everybody's wondering why their deployment processes take 45 minutes, right? It's a pretty easy answer to that. So, and then the last piece is we're relying on monitoring tools that will give us sort of spot checks. What are individual functions and services doing? What is their health? What we don't get is the health of the overall software system, the overall sort of, pipeline of events that ends up producing the final result for whatever the request was, right? And understanding that whole system and its health over time, abnormalities, all that kind of stuff becomes really important, right? So what we're observing and what folks that are very successful are doing, number one is picking my favorite 2 words when I go to clients or when I do QA of our internal projects is you need to have a reference architecture, right? Sort of a reference model, the shining city on the hill that everybody is aspiring to. And one of the major pieces of that with a serverless architecture is using a consistent framework to manage resources. There are a couple of them out there. We tend to prefer the serverless framework. If you guys are in the room, you guys built an awesome application. Just to manage and orchestrate the different components within AWS, the different pieces of your overall software system, and make all that work together, have your nice CloudFormation templates and all that, and build it in a consistent way so that folks from different teams, different product lines can understand what's going on and streamline all of the sort of resource provisioning processes and things like that. Using the platform services as much as possible, we'll get into that a little bit more, but there's a lot of great stuff that can supplement Lambda, and putting things that are not business logic in your Lambdas is can sometimes be a bit problematic in terms of overall performance and sort of overall anti-fragility in a system. And the third one is written in an interesting way. We probably could have fixed that. But what we're trying to say there is reduce the size of code that you're deploying into Lambdas to a minimum, right? I don't care if you do 50 deploys a day. If you have a 10 meg file that you're trying to shove in there, you're not going to have a good time with it, right? So pull out the dev dependencies, do good bundling, all that kind of stuff. We'll talk about that a little bit more. And then, of course, use good visualization. So first major point here, don't use Lambda for absolutely everything. There's a lot of great stuff in the AWS service catalog. Choose the components that you need rather than shoving a bunch of custom code in a Lambda. It will make all of our lives easier, right? So taking advantage of the stuff that's in the API gateway. So using, for example, velocity templates to do simple data transformations. So I've seen this many times now where there's a simple mashup of some information to create a new JSON file, or converting something over from XML from a legacy system or something like that. There's no reason to go build a custom function to go do that every time, when you can just build a simple template in the gateway will take care of it for you, and then you can focus on using Lambda for the actual business logic. So if large amounts of data ingestion are required, and often enough they are, consider taking the next step into the event-driven architecture world and use a distributed commit log, or a stream of events that you can then subscribe to, et cetera. I saw, and something we're helping a client through in the travel space right now is, when parts of your system go down and you're not able to, say, book a flight or book a hotel room, right? If your architecture is set up such that each of the asynchronous updates that happens. Okay, so we have a booking, right? We have a reservation. Ooh, we have a gate change. We have a flight delay. We have a mechanical issue, right? Your seat changed, right? All of those things are updates that queue up, and if those are sitting on, for example, JMS queues, a piece of the system goes down, they're not able to do the full set of functionality, stuff just piles up on the queues, right? And then when they pull everything back up, suddenly you have a bunch of stale data that you have to process through before you can get back to the real data. So that ends up creating billion-dollar problems of whole systems being down for a couple days, when what we could do instead is use a Lambda, use Kinesis or Kafka or something like that, right? Have all of that data going through, have some logic to be able to prioritize it if we have a partial system failure. So when things come back up, we're not going through stale data and all that, right? The serverless architecture makes that possible. Lambdas make that possible. But using the data streaming mechanism, using Lambda as the event handlers, that's ultimately going to help with throughput and help with some of those business cases that are tough to crack otherwise. And most of the AWS services already expose an endpoint, right? So if you're building logic to orchestrate things, you don't necessarily need to, because it's mostly already there. And certainly use Lambda when you need to input business logic into a set of events that are occurring on your data. So the using velocity templates, I think, is important because it's inside of the API gateway. I'm not sure if it's marketed or as prominent as it could be. We found a lot of value in that, in terms of instead of writing a bunch of custom code and then having to maintain it, writing much smaller configuration files and templates that we can do a lot of those simple transformations in, and not clutter up our code. We tried to dry it up a little bit, right? So using streams, talked through this a little bit already, but I think there are a couple of important points here. If we're going to use if we're going to use Kinesis or we're going to use Kafka or something like that. Specifically with Kinesis, if we're pulling in a bunch of asynchronous data, like the updates that we were talking about, the second point, or the second bullet point here of we want to tune the event source mapping batch size to just under 100 milliseconds, right? So the charging model in Lambda is every 100 milliseconds you incur, you're going to get charged for it, right? So a lot of times we'll see folks that have function executions that are 5 milliseconds or something like that, right? And each time they're doing that, they're getting charged for 100 milliseconds. So if we try to micro batch up some of those transactions, get it to 75, 80 milliseconds, we're first of all not wasting money, and secondly, we're actually working within that execution cycle pretty well. So we save a little bit of time, and we also save a little bit of money, and get a good value out of the functions. Next piece is when we do use lambdas, and we should use them prodigiously but intelligently, we need to be nice to them. They're not. If they're angry with you, they will make that presence known. So use a bundler. So use something that will pack up your code, remove the dev dependencies, remove a bunch of the stuff that's not needed for production code. Webpack is a great one. Using a gulp script or something, or a grunt script beforehand to go through and optimize and chew through that code. Right? I think we've all done that in many cases in existing applications. For whatever reason, it's become a pattern that some of those best practices are not necessarily followed when people are throwing things into lambdas, because lambdas are magical and they solve all your problems, right? So, using good bundling, packaging up your application well before you zip it up and send it off is always preferred, and it will solve a lot of problems before they begin. And stop you from incurring a bunch of tech debt that you really don't want to deal with later. Ensuring that the dev dependencies are not included. I think I've mentioned that 3 times already, but I've seen it like 12 times in production, and people are really worried that their applications are huge and that they're taking a while to process and all of this. And it's like, okay, let's just slim it down, figure out the bundling mechanism, and we've just saved you 1/3 of your processing time. It's magic. A couple of sort of deeper points here. Lambda containers can persist across invocations, right? So if we have a bunch of stuff related to one particular function, it's usually a really good idea to include all of those functions into a single handler, so that if we're calling one of the more rarely called functions in that invocation, we're not incurring the cold boot issue, right? We're not including the boot up time. So everything that deals with, say, profile information or ticket information or tax information, right? Include that in a single set of event handlers. You'll end up bypassing one of the larger trade-offs that you get with using Lambda. And I think the next one is equally important, which is if you have things like your IM data or some other sort of persistent cross-function data, you can instantiate that outside of methods, and then it doesn't get blown away, right? So you're not going back and invoking services every single time. You're using persistent objects well, which also helps you avoid some of the cold boot issues. So next point here, which is one I get kind of passionate about because I've seen this a couple times where folks have had some production issues that they probably didn't necessarily need to have. CloudWatch is great when you're trying to measure very discrete things like CPU on a box or how a single service is running. It doesn't necessarily deal with time series data across a whole software system particularly well. So what we've ended up working through with a few clients and putting out there in the wild is something that has worked pretty well for us, which is, and Tom mentioned something similar, right, where you put it through Prometheus, it's timestamps and sort of organizes the data in a way that it can be interpreted in a time series fashion. And you get really nice visualizations of that data. So if you do a request, for example, we'll use my booking example from earlier, right? You do a request to book, you get booked, something changes, you get a notification, that notification invokes a service, right? I want to see that that sort of trend line and how all of that works together and whether it's working together well. And if once we get a good amount of time, we know what our upper and lower control limits are, we know whether the system's in good health, then we can start to say, okay, if there's an abnormality, what do we do to it? Where do we set our alerts, right? And we're setting that across making sure the entire system works as opposed to sort of organizing pieces, which becomes a sort of a really heady operational problem when you don't actually have any console that you can log into and run top and figure out which process is going awry. So the last piece, and I wanted to save a good amount of time for this because I want to connect some of this stuff back to business value, right? I think one of the things as technologists that we sometimes have a hard time with is what is the value of an event-driven serverless architecture? Go explain that to a chief marketing officer, right? It becomes a bit difficult because there's a lot of heady concepts in there. So I want to talk through a brief example of where we've implemented first a microservices architecture and now in another client we're doing it in a serverless manner. Something that I think is kind of cool and revolutionary, right? Where, so if you imagine core banking activity, right? We'll get into one of the biggest industries and one of the hardest nuts to crack here real quick. So we're looking at core banking, right? When you're just doing stuff like pulling a transaction list or making simple calls back and forth, right, to get your data. Reads outnumber writes in that instance in most folks in the industry by about 10-fold, right, or a little bit more. So you're getting 10 reads for every write. Most of these systems are sitting on the mainframe, right? They're sitting on systems that were in many cases written 30, 40 years ago and also continuously written for 30 or 40 years, right? So a colleague just told me the other day, one of the banks in the UK had a major issue. They had to bring in a consultant that was a 90-year-old developer who took 2 weeks to fix their problem, right? And she did awesome stuff, but that's probably not a resource that you want to rely on a whole lot for billion-dollar systems, right? So what do we do in that instance, right? How do we crack that problem? Because all of that stuff is interrelated. It's been continuously developed for 30, 40 years. There's gigantic JEE systems sitting on top of it that are probably just as bad in terms of their coding and being giant monoliths, right? So we have a huge problem there. So one of the ways that we've chosen to look at tackling it is tackling it with first of all, sort of a microservices type concept, and secondly, applying serverless architecture to that. So if you can imagine, every time you run a transaction, whether it's read or write, that you incur MIPS cost on the mainframe, right? So if you're running, say, $40 million worth of mainframe transactions, that's $40 million you can't use on something else. And it's actually a drop in the bucket for a big bank and what they're paying for mainframe. So what we did was basically take the whole system, did a translation over into the back end was Hadoop, the front end was a bunch of services that are being composed as first as microservices in Java. Now they're moving a lot of it over to serverless functions, and I think we'll get that entire architecture in that direction at some point with some other clients. But I think so. The how we did that was basically every time. A database is composed of two things fundamentally. It's composed of the data and then the commit log. So if you just read the commit log every time something's committed and translate it over to Hadoop, we ended up getting sub-second replication time. That became really handy because we were able to do all of the read activity from the new system, right? So any actual writes just got routed back to the old mainframe. We're preserving all of that business logic there to start with. Read activity comes from the new system. And since we all know, if you look at Lambda and the cost of it, right, it's pennies on the dollar compared to traditional methods. What ended up happening was a 60% reduction in MIPS cost, right? So if we take our $40 million, right, we've shaved away 60% of that in 12 months. You take that business case, you take that to any CFO, you say you have a 12-month payback period, right? You're going to get greenlit on your project, most likely. So we crack the first nut, right, of moving the read activity. Then suddenly all these interesting avenues pop up for us, right? And if we follow some of the principles that we talked through before, and we build an application that starts to shave off some of those core activities, right? Which I think the industry in financial services is very much moving toward right now. You can, and they're running into this problem of actually attacking that big monolith. So if we have the read system off to the side, suddenly if we need new functionality, we can put it in there and start to reroute things and apply the strangler pattern to core banking, right? So we're talking about multi-billion-dollar problems that we can solve with novel architectures without a whole lot of risk, right? So I think the thing that is great to take away from that is all of this will end up, it's something that you can really fundamentally change whole industries with. And building serverless applications, as long as we avoid a lot of the pitfalls that we mentioned a moment ago, you can really start the clock over in terms of lots of tech debt, and maybe you won't need the 90-year-old developer to come out of the retirement home to help you solve your problem with tax data being mismatched or something like that, right? So a lot of momentum on that side of the house. Also a lot of momentum in using serverless to just solve simple business problems, right? If we don't have to worry about all the infrastructure, if we can have a consistent method of deployment and all of that, we can really empower developers to solve problems on individual products and decompose things into a set of modules that work to actually solve those problems, right? So I think the messianic message, I guess, or the evangelical message is drink enough of the Kool-Aid to take this to business leadership and say, if we do this right, we can give you the 12-month payback periods. We can give you the functionality that you were looking for. I'm working with a hospitality client right now with their core reservation system. And how many of us stay in hotels fairly regularly? Okay, got a couple of fellow road warriors around here. So wouldn't it be nice if you could just choose the actual room you want to stay in? Be kind of cool, right? None of the big reservation systems can do that today. It's a pretty open secret, right? They can't do it because they were never engineered to do that. Decomposing and building this stuff in this way, you will see that kind of functionality, or walking into the hotel and your room will be tuned to the temperature that you usually like your room. I like to sleep in a freezer. So if it's 75 degrees in the room, I'm not happy. So if it gets turned down to 68 automatically, it's just one more little thing. But actually orchestrating that through existing systems is very difficult, right? Orchestrating that through serverless and doing some simple IoT stuff to make sure that you have a smart thermostat. We've prototyped stuff like that to show to client executives or client boards in 48 hours, right? The stuff is game changing, and I think all of us can take that message and be the heroes in our particular industries and groups. So I'm gonna skip past a couple things here. All right, so thank you all for coming. If you have any questions, certainly come up and chat with us here in a moment.
Mike's on the sides.
Yeah, we got two mics here. Please visit us at booth 829. We have some more demos. I'm going to hang out there a little while. Tom's going to hang out there a little while. We have some other experts that are solving some of these issues for clients. So if there's any questions, we'd love to take them now.
Ladies and gentlemen, please exit the open doors. Ladies and gentlemen, please exit the open doors.